the first example, example 2.3.1 on the proving related to mathematical inductions. So we want to prove that 1 plus 2 plus 3 plus and so on up to terms n is equals to half of n multiplied by n plus 1 for every natural number n. Okay, so we highlight the case for n here, which is we want to look into for every natural number n. So that means our case for n here is for natural. So n starting from the points n greater than or equals to 1. So the first case will be n equals to 1. Right, so we look into the proof. First step, make this as your practice. So let's denote our general statement first, which is we use Pn to denote our statement. So our statement is what? 1 plus 2 plus 3 and so on up to terms m will be equals to half of n times n plus 1 for all n belongs to or for all n greater than or equals to 1, where our case n is natural. So n1, n2, n3, and so on and so forth. So the step in mathematical induction, the first one, we need to show that the basis for induction is true, which means we want to check for the case of Pn equals to 1. Okay, so what happened to the equation that we have here? Okay, we have these equations. And what will be this equation when n replace equals to 1? So from the left-hand side, so this is our left-hand side. And this is the right-hand side. So we need to check for the case of n equals to 1, the left and the right-hand side are equal. So the left-hand side, we have what? Left-hand side. For the first case, we have 1, correct? The first term will be 1. So the left-hand side is not you substitute into the n, but the left-hand side refer to the first case, which is 1. And the right-hand side, then we substitute the value n. So right-hand side, we have 1 over 2. So case n equals 1, then we substitute n equals 1 into the formula. Okay, so that we are going to have 1 plus 1, which is you will get 2 and 2 will cancel. So this will be equals to 1. So now we have left-hand side equals to the right-hand side where both equals to 1. So this indicates that the conclusion P1 is true. Okay? So that means we have shown that the basis case is true or P1 is true. So the second step in mathematical induction is what? We need to show the induction step, where induction step consists of the statement if Pk is true, then Pk plus 1 is true. So our antecedent is what? Our antecedents or hypothesis is we need to assume that Pn is true for the case of n equals to k. Right? So we write like this. Let Pn be true for n equals to k. For any case of n equals to k, but we need to remember that n or k here is actually referred to natural numbers. Okay, so if k refer to the second, then the next will be number 3, so on and so forth. Okay, so what it means when we say this one, so it actually means that we have this statement pk. Okay, so our statement pk will be what? 1 plus 2 plus 3 and so on up to k terms. This assume to be true, which means this will be equals to half of k times k plus 1. Right? So remember, this is the antecedent, which we assume this is true. Meaning to say that we accept this equation to be true. If you have 1 plus 2 plus 3 plus on up to terms k, it can be replaced by the formula half k times k plus 1. Okay, so that is our antecedent. So now we want to show that, okay, so we want to show pk plus 1 is true. Okay, so how? We might use, and usually we are going to use our assumption steps here to show that pk plus 1 is true. So if pk plus 1 is true, then how the equations looks like? Okay, you can see that from pk, we can write the equation that represent pk plus 1. So if pk plus 1, we can have this equation. So 1 plus 2 plus 3 and so on up to terms k. This is terms k. If pk plus 1, that means we need to add another term where that is terms k plus 1. Okay? And if this is true, what will be the formula on the right hand side? So meaning to say that pk plus 1 here is referred to the value n, where in this case, we replace n by k plus 1. So the right hand side will be what? The right hand side will be half of k plus 1 times k plus 2. Okay, so we replace this by k plus 1. We replace this by k plus 1. So that you have factor k plus 1. And the second factor is k plus 1 plus 1, or equivalently, it is k plus 2. So we have the same. We have the left hand side here, and we have the right hand side. So here, the steps here, we want to prove that is that the left hand side equals to the right hand side. So we can use our our antecedents here, where we assume that pk is true. So if you look into the statement on the left here, okay, if I highlight the first k terms up to this one, okay, so we can replace that one where the first k term here is actually our assumption, where we assume that one to be true. That means we can replace the first k term by the formula half k plus 1. So the left hand side will be what? The left hand side will be, so this term, okay, we replace by this formula, so that you have half k times k plus 1, and we have this term, so plus by k plus 1. Okay, so you need to show that this will be equals to, is it possible? You should be able to simplify so that you will have this one. Okay, so if you can show that, meaning to say that you will have this is equals to the right hand side. Okay, but I leave it for you to prove on that one. It just you need to do some factorizations. Okay, then you should be able to prove that the things that we have on the left here can be right as this one. And if we can do so, that means we have shown that Pn is true for n equals to 1. Pn is true for for n equals to k, and Pn is true for n equals to k plus 1. Then we can conclude that the statement 1 plus 2 plus 3 plus n is equals to half n times n plus 1 for every natural numbers. Okay, so that is the first example. Thank you so much.